Now we are going to do numerical problems, the third type of questions in the IIT type question paper. If a cell, problem number 13, a cell of EMF, constant EMF produces the same amount of heat during the same time in two independent resistances R1 and R2 when they are connected separately one after another to the cell, then find the internal resistance of the cell. So this has, the two concepts are used here. One is concept of internal resistance, another is concept of heat developed. First let us see the internal resistance. So you take a cell of EMF E and internal resistance R. When it sends current through the external resistance, the internal resistance of the cell will come in series. Therefore, the current through the external resistance will be E by R plus R. That is the first point. Okay. Then the heat developed is equal to I squared RT. So we have been given H1 equal to H2. That means I1 square R1T equal to I2 square R2T, or I1 squared R1 equal to I2 squared R2. Substitute for I1 and I2. E is same, R is same, but this is different. So whole square into R1 equal to E by, in the second case when R2 is connected, this is I2 R2. What all we can cancel? We can cancel this E. Then it will be R1 by R plus R1 whole square equal to R2 by R plus R2 whole square. Now take square root on both sides. So we get root of R1 by R plus R1 equal to root of R2 by R plus R2. Cross multiply root of R1 into R plus root of R1 R2. Here root of R2 into R plus root of R2 R1. Now rearrange root R1 minus root R2 times R. On this side we are going to take over here, and we can take root R1 root R2 common factor. So this will become root of R1 minus root of R2. So you can cancel here. So what is the answer? So R is equal to root of R1 R2. So the answer for this numerical question is the internal resistance R equal to root of R1 R2, and if R1 R2 values are given, you can substitute and find the value of R, the numerical value of